So we got this diagram, we got two ropes, and you got a question is how much work is done by these different things, the force, the kinetic force, and then tension 1 and tension 2. Let's get some space out of the way. So we've got our diagram right here. So I'm trying to find the work done by WFK. We know work is basically force times distance. But don't forget that the sign matters. So it's important that you use the correct sign. And obviously, in the case of the F sub K, the force in the K, that's in the negative direction. And then the tension forces of the ropes are in the positive direction. So just the force done by the K is going to be just, in this case, 500 newtons times the distance. And what was the distance? It was 6. And actually, it's actually negative 500 times 6. That's the answer for A, if you will. For B, now the trick on this, of course, is you have to play a little bit of trigonometry. So again, it's only going to be the force in the x direction for T1 and T2. I think they asked for T1 first, yeah. So they're asking for what is the net work in the of T1. Again, it's just work is force times distance. But you're going to have to find the force using, it's going to be cosine, right? So like for T1, the force, T1, if you will, x, would be equal to 326 cosine of 20 degrees. Make sure your calculators are in degrees and not radians, and then you could solve this. Now this force is in the positive direction, so your numbers will be positive when you're signing for the work. And as a note, don't forget what are the units on work. Work is always measured in a joule. And the same thing for T2 or question C, because on that one what you're going to do is, of course, use cosine again, because it's a positive x, and it'd be cos 30. And yeah, I think you can solve it.